Happy World Soils Day from the Cranfield University Soil Informatics Group and LandIS Team. We are custodians of the national soil data for England and Wales, and there are over 700 different soil types recognised in England and Wales alone. This data is formed from a long legacy of soil survey over the last 100 years in England and Wales. And this has formed the basis of understanding the soil resources in England and Wales to make decisions about land management. This is the focus of the research in our group. So we're using some of the national data, but integrating it now with novel technologies, such as sensor information. We're also using advanced data science techniques and machine learning and modelling. And by integrating all of these things, we can begin to understand how the soils are responding or changing to different environmental pressures, such as climate change, and also the way that we manage soils under different land uses. Did you know 95% of our food comes from soil? Have a think about what you have for breakfast and think about all of those things that you've eaten, and the majority of them will have been derived in some form from the soil. By 2050, we will need to increase agricultural production by 60% to meet the demand for food. And these are the sorts of questions and issues that we are addressing through our research using soil informatic approaches.
LandIS is a core digital repository that holds the fruits of many decades of field soil survey, which led to the publication of many reports and award-winning maps. These materials were captured in computer form to form the Land Information System, LandIS. Today, LandIS, supported by DEFRA, is the point of reference for the information on the soils of England and Wales.
Well, here in the Soil Archive, we have a range of soil materials like this, which tell us about a wide variety of applications and uses of the data. The soil survey information we have was originally focused on food security in the post-war years, but subsequently the data has been used in a whole variety of different types of application, from environmental impacts, biodiversity, geohazards, the built environment, planning and financial sector applications. So the soils data finds a wide variety of uses. We hold not only the soils data for England and Wales in our LandIS archive, but we also have the World Soil Survey Archive and Catalogue, or WSAC. And these maps are just part of that extensive archive held here at Cranfield University. These soil data are used for a range of application themes, supporting the ecosystem services, whether it's the provisioning services, such as the production of energy, biomedical, national defence or transportation. Somewhere soil is in the answer to that. Whether it's the regulating services, the provision of clean water, flood prevention, climate regulation. Again, soil can play a part in finding the answer to these themes. And also cultural services, which are very important to do with well-being and heritage and the protection of artefacts in the soil. Again, the natural environment and soil plays a key role. And importantly, the supporting ecosystem services, nutrient recycling, productivity of the primary land, and also the biological diversity and the maintenance of that. The information we hold here also has a direct bearing on the way that we can address the United Nations Sustainable Development Goals. And soil plays a role in addressing many of these goals, be it Goal 2 concerning zero hunger, be it Goal 11 on sustainable cities, the development of sustainable cities, or 12 on responsible production from the land, 13 climate action, and of course 15, which is life on the land. In all these cases, soil plays a key role in answering some of the complexities and questions that arise in addressing these.
I'm a soil ecologist and ecological modeller. I develop models at different scales using a diverse range of methods to predict how soil animal populations will respond to different global drivers like land management practices and climate changes in the future. The information contained in national soil datasets like LandIS are really crucial inputs to these models, containing breadth of information about how these soil abiotic conditions, which really drive these animal populations, vary at different landscape scales.
Working with soils does not always involve going out to the field to get soil information. Instead, we can make use of existing soil information on soil classes, properties and functions to generate maps of soils in a process called digital soil mapping. Digital soil mapping utilizes machine learning methods to link observed soil properties to information on soil formation factors such as climate and topography to map soils at an unsurveyed location. Digital soil mapping allows for generation of soil maps at much lower cost as compared to traditional soil surveys and can be used to complement the surveying effort required to map an unknown area, whether it is a field, a region, country, or even a continent. A prominent example of using digital soil mapping at a country level was the production of a harmonized soil map at 1 to 250,000 scale for the Republic of Ireland.
Soil is an essential component of environmental modeling processes. Integration of soils with wider environmental datasets, such as future climate, help us predict the future changes in the grades of agricultural lands and help policymakers decide about land suitability for various purposes. Using the guidelines and criteria to generate such maps and the baseline climate, we first predict the baseline agricultural grades. The baseline climate refers to the climate before 2000. Here I show the input data I am using. Climate data at 5 km grid spacing, the national soil map data at 50 meter resolution, topography of England at 50 meter resolution, and some ancillary soil data. To reduce computational burden, we divide each 5 km grid in 4 subgrids: northwest, northeast, southeast, and southwest. Each of the subgrid at 50 meter resolution has 1000 by 1000 data points, and there are a total of 93 such subgrids for the whole of England. I am writing a Python script to generate the predictive maps. I am reading each of the raster data as a data frame, and to reduce computational time, dividing the data frame in multiple segments and run Python multiprocessing to handle each data frame. Finally, I merge all the output data frames then. The next step is to run the script for all the grids and generate the baseline ALC map for England. Then, using future climate, we can run the simulations again to generate the future agricultural land classification in different climatic scenarios from low to high emission.
We developed a series of digital tools to assist the widest access to the holdings that we have at Cranfield University, making it easy to access and use LandIS soils information. So here we have reports showing the spatial distribution of soils, the texture triangle of soil characteristics, and pesticide runoff risk, by example. These reports can be customized for a range of users. We have standard reports and dedicated reports for different sectors, telling us about the soil properties, spatial maps, all held together in the Soil Site Report, available from LandIS website.
In Cranfield, we've developed a range of technological approaches that will help a new generation of users to access and make beneficial use of the soils data that we hold. We use new and innovative ways to access and share the soils data. The collaborative tools we use include immersive virtual reality environments to help users experience the great variety of soil types and landscapes in England and Wales and worldwide. Technologies such as these help our users to interact with and extract information from the wide range of soils data that we hold in LandIS and WASAC. Also important is being able to combine the soils data with other types of environmental and societal data to aid our understanding of the likely consequences of the changing climate.
Soil-related materials for England and Wales into landis.org.uk website and international materials into wasite.com. landis.org.uk provides a one-stop point of reference for information on the soils of England and Wales. We also offer a range of web tools, apps and APIs in order to help users interact with soil holdings.
Hello, my role is data licensing and client management. Our aim is to offer a comprehensive range of soils data to businesses, the environmental sector, the water industry, councils and also for bona fide academic use. We're always interested to find out how our data is used by such a wide variety of organisations, and we request copies of papers and final reports. These provide a fascinating insight to the use of soils data to prospective clients.
We are really pleased to support World Soils Day at Cranfield University to raise awareness of this really important natural resource, to understand its fundamental importance for all of our lives, and to look after the stuff that's beneath our feet.